we will use the Docker image. We will still use the Azure Container Registry, but we will be using Kubernetes to deploy our images. Okay. Now, first, let's talk about Kubernetes. So before, by the time we are talking, so let me just open the Docker desktop, because without this, we will not be able to create an image. Okay, yeah. So Docker desktop. So this is what let it start. Okay. So by the time it's starting, so today we'll walk through the process of deploying a Docker image to an Azure Kubernetes service or AKS cluster. Okay, we'll break down the purpose of each command, and then we'll also provide you explanation how they work together and to achieve basically to achieve container orchestration. Okay, now let's understand the process. So container orchestration is about automating the deployment, scaling, and management of containerized applications. Okay, Kubernetes is a very powerful open source platform for this. Kubernetes is basically owned by Google. Okay, but whether in uh, AWS or Azure, in Google it is called Google Kubernetes Service, GKS. In Azure it is called EKS, and in AWS it is called EKS, and in Azure it is called AKS. Okay, Azure Kubernetes Service. So AKS or Azure Kubernetes Service basically simplifies using Kubernetes on Azure by managing the underlying infrastructure for them. Okay, and like if I can say with a simple or if I can use a simple analogy, so think of a container as a like a single musician with their instrument. Okay, you could manage each musician individually, but it's more efficient to have a conductor, which is now the Kubernetes, who can manage the entire orchestra or your series of containers. Okay, ensuring they are all playing in sync, and that when a new musician joins in, or like it can manage if you can bring in another musician or another container, or if a certain container is left alone. Okay, now let's go ahead and look at the exact steps. Okay, so I'll share the file with you as well. Okay, in that same folder. Now, okay, let's go through the code. Okay, second. Okay, so the first step is basically like if you have already not installed it, then you have to use or you have to install Azure command line interface. So basically, okay, so you can use this to install Azure command line interface, but I have already installed it, so I'll not need this one. Okay, but you can use this winget install Microsoft.Azure CLI to install it. Okay, now, so I'll not be needing this one, but what I'll do, I'll just change my directory. So I'll use CD, then C, and then Python, because this is the place where all my files are. So basically, I'll change my directory at the initial step itself. Okay, now once I've installed my once I've installed my command line or once I've installed Azure command line interface locally, then I can also, using this particular command winget install Microsoft.Azure CLI, I can look and see like what is the version. Okay, now the next step is basically the next command simply checks the version of the Azure CLI you have installed, and it's a quick way to confirm that the CLI is set up and ready to go. Okay, so we can use AZ and then version. Okay, so if you do that, basically you'll see Azure CLI 2.77. So this is the latest version. So we have the latest version installed. Okay, now next I'll use something like AZ login. Okay. Now, if I'm using AZ login, I will not be able, because I am not using tenant, right? So there are some limitations in terms of how I can log in or how I can do stuff. But if you are using single sign-on kind of scenario, or if it has been configured on your machine like a single sign-on, then you can directly use AZ login and you're good to go. Okay. But in my case, what I'll do, I'll use another additional step, use device code. Okay. Now, if I'm using device code and I just do enter, then basically it will help me, or it will give me another link and a code which I can use to log in. Okay. So now basically I can do control click and it will take me to a new page, but I have not shared it. But yeah, once you click it, it will just ask you for a password, and then you can just put in the password or the code that you see in front of you. Okay. Just a second, I'm just logging in. Okay, so now I've managed to log in. Okay, now now it'll ask you for a subscription or default tenant, but that's fine. You don't have to provide. So now you have logged in. Okay. Now the purpose of this command is basically this command authenticates your local machine with your Azure account, and the device code option provides a code that you can use on a web browser to log in, which is useful for environment without a without a GUI. Okay. Now next, what I'll do, we bring in the next piece. Okay, next I'll create a resource group. Okay, so okay, so one second. Okay, so next I'll go ahead and create a resource group. So, I mean, this particular command basically creates a resource group in Azure. As we have been discussing, a resource group is a logical container that holds related Azure services together. And it also helps you manage all the components of your application together, like Kubernetes cluster or any other application, not just related to Kubernetes, even databases, storage, everything it holds together. So so basically, if you want to get rid of all the services, I mean, all the related services, if you have created all the services under a certain resource group, if you delete the resource group, all the services under that particular umbrella will be gone. Okay. Now, what I'm doing is AZ group create name AKS demo RG. So this is the name of my resource group and location, and I'm providing East US. But if you want a different location, depending on your need, you can provide other location. Okay. Okay, so now you can see the output. So this is the subscription, location, manage body limit. So the name of the resource group and properties, all these things have been populated. Okay, so next we will run this. So let me go through what this does. So this particular command creates an Azure Container Service. So Azure Container Service, as we have been doing earlier, is a private Docker registry where you can store your Docker images. It's like a private library for your container images, and this I mean it makes them accessible to your Azure cluster services, or sorry, Azure Kubernetes services cluster. And what we have done here is basically we have provided the ACR service name. Okay, I mean, we are creating it under the resource group, that the one we created earlier, AKS demo RG, and the name of this container registry is AKS demo ACR diamond 01. Okay, this is the name of the registry. Okay, now next we have to do is we have to tag our local Docker. Okay, so let me also do that. think I missed a step, but yeah, let me just do that as well. Okay, so I mean, we will use the same files that we had used earlier. So we will use processor data app v1. So the Docker image that we have created earlier. So we will build the Docker image. So now Docker build T. So this is the name and the version, and the location is the current location. Okay, so now let's go ahead and build that. Okay, so now we have built our Docker. Now let's tag our Docker. Okay, now let's tag our Docker to the ACR or a container service. Okay, so to do that, basically, second. Okay, so this is what we'll do. Um, Okay, so Python Docker tag process data app v1. So this is the container registry. Okay, and then slash. So this is basically the format. So now I'm executing. So this particular command or this command tags our Docker image. A tag is basically kind of a label that includes the name of the container registry or Azure Container Registry and the desired image name and version. Okay, this step is crucial because it tells the Docker where to push the image. Okay, now next step. Okay, so this particular step or this command authenticates our local Docker image with our Azure Container Registry, and this also allows us to push images from our local machine to a private registry. Okay. Great. Okay, so login succeeded. So now we are good to go. Okay. Now, okay. Next step is basically, okay. So this step is Docker push. Then the container details is basically, did I use it earlier? Okay, no, that's fine. So this command basically uploads our tagged local Docker image to Azure Container Registry. Now the image is basically stored in a centralized secure location where Azure Kubernetes Service cluster can access it. Okay. Let it build. I mean, let it get deployed. Okay. So now the push is successful. So next step. Okay. So this particular step, one second. Just move this to up. Okay, now this particular step. So the purpose of this command is, I mean, this command basically creates our AKS cluster, and this is where the container orchestration happens. Okay, node count one basically means it creates a cluster with one virtual machine or node to run our container. And then enable managed identity basically means like this is kind of a best practice for security. This option basically gives the cluster a managed identity to access other Azure resources like container registry. And then we have this generate SSH keys, which basically creates keys for securely connecting to cluster nodes if needed. Okay. Okay, it will take like a few more seconds. I'll just pause the recording. Okay, so now as I said, so my AKS cluster is ready. Okay, now next line. Okay. Now, this command basically retrieves the object ID of the AKS clusters. Uh, I mean, object ID of the AKS clusters managed identity. And this ID is needed in the next step to grant the cluster permission to pull images from container registry. Okay. Okay. So what I'll do, I'll just copy this, save it in a notepad. So yeah, so next command. Okay, so the next commands ACR show name, the ACR name, query ID, output TSV. Okay, so this command basically retrieves the resource ID. Okay, first we are retrieving the object ID, then we are retrieving the resource ID of our Azure Container Registry, and this is another piece of information required to grant permissions. Okay, in the upcoming steps. So let me also note this down as well. Okay, got it. Okay, now next step. Okay, just give me a second. Okay, there. So what I'm doing, so this is how I'm modifying it. So role assignment create, then assign the object ID, and then role ACR pull, then the registry ID. Okay. Now, sorry, query ID. Okay. So now if I go ahead and execute, Okay. Now, the purpose of this particular line that I executed is, I mean, this command is very critical, especially for security and permissions, and it creates a role assignment that grants our AKS clusters managed identity, that is assigning object identity, object ID, and ACR pull role. And this role gives the cluster permission to pull images from our container registry. So the scope that you see is, but not to push or delete them. So this is an example of the principle of least privilege. Okay. Now, okay, so we are good. So next, what we will do is, okay, so okay, so next we will be, the next command basically downloads the credentials to connect to local machine to our new AKS cluster. So it configures our local kube CTL or kube command terminal line. So basically tool or kubectl tool to communicate uh, 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 with correct cluster. Okay. Okay. So So, okay, so now this has been configured. Okay. Now, next what we will do, I will share the YAML file with you. So this is a standard format. So let me just execute this and then I'll let you know. So okay. Cube, kubectl apply f job.yaml. Okay. Okay, so what this does, this is a core Kubernetes command. Okay, and it tells the cluster to create a new resource based on the job.yaml file. And a job is a specific type of Kubernetes resource that ensures a containerized task that runs to completion. And this is where the application is deployed to the cluster. Okay, and this is like a standard format for most of the jobs. Okay, and just to understand the Kubernetes YAML, so that is a completely separate skill set just to write the YAML codes. Okay, so we are not going into that now, but you'll get some standard formats, just like the job that I am providing you. Then I'll also provide you another few other formats for deployment as well, just in case if you need something. Okay. Now, okay. So now you see the job has been created. So next we will do is we'll run another core Kubernetes command. Okay. Now, this command basically retrieves information about the pods that are running. So pods basically, imagine the pods are these containers running in the Kubernetes. Okay. So in Kubernetes cluster, basically when the images they run or the containers they run on pods. Okay. Now, yeah, so as I was saying, so this command basically uses a selector to filter the results and show only the pods associated with the specific job. Okay, and just to define pod, a pod is basically the smallest and simplest unit in the Kubernetes object model, and it represents a single instance of your running container. Okay, so now if you execute, so now what we have done, we have just deployed a single pod, right? So only one image we have deployed, so that's why we are seeing only one. So now what happens? You can run any number of pods possible. Okay, so because this is free, see if what is the purpose? I'll come to the purpose in a while. Okay, so now again, the purpose next is basically if I want to see like whether how it has been running and all, so I can also see look at it. So this is the one. Okay, FKFQ5. FKFQ5. Okay. kubectl logs process data job FKFQ5. So now if I execute this, so this command streams the logs from a specific pod, okay, allowing us to see the output of the container's execution. Okay, and this is essentially for debugging and monitoring our application's progress. So now you see, earlier, if you remember in our last class, so this was the output of the process underscore data file, right? So we created a table and then we are displaying the data frame. Remember this, right? One second, let me. Okay. So as I was saying, there could be many use cases for using containers, but one of the use cases, if you ask me, is suppose for instance I am having Databricks. A lot of these ETL tools or ML pipelines are running in Databricks. Okay, where we are pushing the data into Unity Catalog, and then from Unity Catalog, I'm using the data for any purpose. Okay, now there are some instances or there are some services which I need an ETL job or where I just need a job, okay, but I don't want to bring there maybe just to populate these log files, or there could be something I don't want to spend a lot of money on it, okay. In that particular scenario, I can just go ahead and use Kubernetes. So what Kubernetes is does in this Python code, whatever I have defined, it will do. Okay. Now, once I've defined it and then I have deployed it. Okay, so in Kubernetes, so it's not just one pod I can deploy. I can deploy any number of pods. Even there are a lot of people or a lot of organizations who are just using Kubernetes. They are not going into those ETL pipelines, their flow or all those things. They're just using Kubernetes, and then depending on their necessity, that they're just creating that they keep creating these pods, and all their code or everything just is Python based. Got it?